minus 1 over the absolute value of x. Okay, so again, in this case, we could plug in simply x equals 0, but we're going to get 1 over zeros, and that's not going to work. So again, the key to this problem is basically just getting rid of the absolute value in the appropriate manner. That's kind of the whole idea. So again, we saw the definition a second ago for absolute value of x. Again, we said if the x-coordinates are less than 0, we have to tack on an extra negative to make it positive. And we said it was just plain old x if x was greater than or equal to 0. Well, again, in this case, x is approaching 0 from the left, so that means we're using x-coordinates less than 0. So we need to replace our absolute value of x. Again, we're going to replace this absolute value of x with a negative x, okay, based on this portion of the definition of absolute value of x. Okay. So, all right, well, that's at least the first part down. We still have to calculate this limit. So notice two negatives make a positive. So really we have the limit as x approaches 0 from the left of 1 over x plus 1 over x. Well, we have common denominators, so we can simply add 1 over x and 1 over x to get 2 over x. Okay, at this point things are almost simplified down. A couple different ways you can think about this limit. So to me, we're taking 2 and we're dividing it by a number that's close to 0, but it's negative. Well, if you take any fixed number, here like 2, and divide it by a number that's getting closer to 0, first off, the absolute value of the number will get large. It'll go towards infinity. So 2 over a number that's getting smaller and smaller and smaller is going to go to infinity, but since it's negative, it's going to approach negative infinity. So we can conclude this limit is negative infinity. Likewise, if you know the graph 1 over x, 2 over x looks basically like the same thing. So 1 over x does this, and then it goes down over here. 2 over x, it's just going to be a stretch, but it still has that same shape. So again, as you approach the x-coordinate of 0 from the left, it says you're going to go down towards, the y values will go towards negative infinity. Okay, so I hope these couple of absolute value problems make some sense. If not, feel free to post comments, or if you would like to see some more complicated ones, let me know and I'll try to get some out there.
Okay, here's another limit problem, and this is a useful limit to know. It's just another one of those random little formulas that are worth memorizing. So it says the limit of theta goes to 0 of sine theta over theta equals 1. And you can actually flip over this fraction and make it into theta over sine theta as well, and still have that equaling 1. And again, if you try to plug in check method, if you plug in theta equals 0, you'll get sine of 0, which is 0, and 0 on the bottom. So you get 0 over 0. There's a couple ways to justify this. In the calculus book I have, they actually go through a relatively complicated, I wouldn't say super straightforward argument. You can also use L'Hopital's rule if you've seen that, and there'll be a video where you can check out some problems using the L'Hopital's rule. But in any event, let's just take it at face value and do a couple examples using this identity. Okay, so the idea basically, the way I think about it is, it says, okay, you have sine of theta over theta. It says whatever you have next to the sign, you want the exact same thing in the denominator, as long as the stuff inside the parentheses is going to 0. Well, in this case, I have 3x on top. Well, I would like to have a 3x in the bottom. Well, let's just make that happen. I'll multiply the denominator by 3, but if I multiply the denominator by 3, I also have to multiply the numerator by 3. Okay, so there's my extra 3. Again, notice I could just cancel those out and be back to my original problem. And now I can use this identity on it, this limit result. It says I have the same thing next to sign, the same thing on the bottom. The stuff on the inside as x approaches 0. This is certainly going to 0. This is certainly going to 0. It turns out that this whole limit is 1. And I still have to multiply that by 3, so my solution will be 3. This is a touch more complicated. I'm going to rewrite this. I have the limit as t goes to 0. Again, you should check. If you plug in 0, you get sine of 0, which is 0. On top, you'll get tangent of 0, which is 0. So we do have 0 over 0. I'm going to rewrite this so that I have tangent of t over 1 times 1 over sine of 2t. Squeeze that in there. Okay, and now I'm going to rewrite tangent of 6t as sine of 6t, and this is divided by cosine of 6t. I'm going to put the cosine of 6t over here. Okay, so this is over 1. You can think about a 1 being up here. And then I still have my original sine of 2t in the denominator. I'm not putting my over 1 and my 1 on top and my 1 on the bottom just yet, because I'm going to start filling stuff in. I am going to put one of them right there. So now I start thinking about these two original identities again. It says whatever's next to the sign, I either want that same thing in the bottom, or if sign happens to be in the denominator, I want that same thing in the top. Okay, well, I have sine of 6t here. Well, I'm going to multiply the denominator by 6t. That means I have to multiply the numerator somewhere by a 6t. Okay, well, let's just remember that for a second. On the top of this, I would like to have a 2t. Well, I've got to multiply the numerator by a t somewhere because I added this t in. Why don't I put that extra t that I would like on top here? And I still have to multiply the numerator somewhere by 6. So I'll just bring my 6 out here. Okay, so now this one looks exactly like I would want it to. I've got my t would cancel out with this t, my 6 would cancel out with this 6, and I would be right back to where I was before. And the only thing left is, well, I have 2t down here. I would like to have a 2t here. Same idea. I've already got the t. Just multiply the numerator by 2. I'll multiply the denominator by 2. And now I'm finished. I've got sine of something divided by that same something. Again, oops, I've got thetas in here. I slipped a theta in here. There should be a t. If t goes to 0, the inside goes to 0, the bottom goes to 0. So this whole limit is going to turn into a 1. Okay, this we have to actually evaluate. If you plug in 6 times 0, you'll get 0. And cosine of 0 is 1. So I'm getting 1 over 1 from this part. Again, this limit is going to be just plain old 1. And then I'm left with 6 divided by 2, which is 3. So it says my answer to this problem is going to be just plain old 3. We really won't run into these types of limit problems too terribly often, but it's one of those weird little things that you will see, just enough to where it is worth remembering these basic limits at the very beginning.